Okay, so I can see a 6, I can see a 5. Okay, no problem. So let's go through this together. It says a curve has equation y equals g of x. And it says, given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x. Second bullet point, the curve of equation y equals g of x passes through the origin. And the last bullet point, the curve of equation y equals g of x has a stationary point at 2, 9. Find g of x. That's for part A and it's 7 marks. Okay, so let's go through it bit by bit. The first bullet point tells me it's a cubic expression, right? Now, remember, so before I even get to the other part of that sentence, right? A cubic expression. Well, remember, if it's a cubic expression, then any expression for a cubic would have 4 terms, right? We're going to have ax cubed plus bx squared plus cx plus d. Are we all happy with this? This is a general formula for any cubic expression you can have. Are we happy with this? Yeah? Okay. Now, they told us in the next part of this sentence that the coefficient of x cubed, right, is equal to the coefficient of x. Now, what does the coefficient of a term mean? It's just a number in front. So I've got this to be a, right? This is the coefficient of x cubed. And I've got this to be c, the coefficient of x. Apparently, these two are equal. These two are equal. So I'm going to say a is equal to c, right? Based on that first bullet point. So if I want to, then I can just say, well, I can say that this cubic then becomes ax cubed plus bx squared. And then instead of writing cx, I'm going to write a because it's the same thing. So I get this. Are we happy with this so far, guys? Does that make sense? Did you see the chat? Yeah, good stuff. All right. Now, let's look at the second bullet point because we've taken everything from the first bullet point. Second bullet point says that the curve of equation y equals g of x passes through the origin. What does that mean? Anybody have any suggestions as to what that means? How can that help us? Right, right. Thank you very much, Emilio. So if it passes through the origin, well, the origin is the coordinates 0, 0, isn't it? Right? Let me just see the chat again. Exactly. Thank you very much, Manya. It's y-intercept is 0, so d is 0. So there's 2 ways to do it. So you can either just say, well, fine. I know that it passes through the point 0, 0. So I've got this as g of x here. So this is going to be my y coordinate 0. And then that means that every single term is going to have a 0. And every single x is going to have a 0, right? Like this. And then like that there. And then what happens is that, well, fine. All of these are just going to be 0. So that just leaves me with 0 is equal to d. And that just means that d is equal to 0, right? So you could just do it manually and plug it in, or you could just say, well, fine. If it passes through the origin, there is no y-intercept. So you can go directly and just say d is equal to 0. But either way, you get the same thing. Does that make sense, guys? We all happy with this so far? Yeah, good. So now remember, you're going to update your equation because you've got a bit more info about it. You're going to say, well, fine. G of x then is now ax cubed plus bx squared plus ax, right? This is what we have so far. Now, what else does it say? It says that the curve with equation y equals g of x has a stationary point at 2, 9. So I'm going to copy this bullet point here. So I've got this here. Now, for me, the most glaring thing that I see is stationary point, isn't it? Right? Stationary point, which we've been doing all lesson. That just means the y dex is equal to 0. But since we're dealing in function notation, right, I'm going to use g dash of x. This just means that g dash of x is equal to 0. And it's at 2, 9. So do we agree then, guys, that when we plug in x equals 2, into our gradient function, we will get 0 out because it occurs at 2, 9. Does that make sense, guys? Are we all happy with this? This is important. Are we all happy with this? Yeah? Good stuff. Good stuff. So now, well, let's differentiate then. So we know that g of x is equal to ax cubed plus bx squared plus ax, right? Now, if I want g dash of x, Now, be careful here. We've got these A's, B's, and A. These are constant terms, right? They're not variables, right? In the same way X is, right? So you're going to treat these like they're actual numbers anyway. For example, if it was a 4, if it was a 5. So if I was to differentiate this, then it would be, well, the 3 will go to the front. It's going to be 3A and then X squared, right? Because the 2 will drop down. And then plus, this would be 2BX, right? And then this is going to be, remember, when you differentiate KX, you go to K. So differentiate AX will go to A. So you get this here. Does this make sense, guys? Yeah, we all happy with this. Just before I continue, this is very important. Yeah, good stuff. Now remember, there's a stationary point that occurs at 2, 9. That means when I plug in X is equal to 2, I will get 0 out. So that would mean here then that I've got G dash of 2 is equal to 3A and then 2 squared plus 2B and then X equals 2 plus A. And then apparently this equals 0, doesn't it? So let's just tidy this up. Well, I've got 2 squared, which is 4. 4 times 3 is 12. This is 12A plus 4B plus A is equal to 0. And then tidying that up, that will just give me 13A plus 4B is equal to 0. Now, I've got 2 letters here and 1 equation. We know that this has to be what topic, guys? What topic is this that you were taught in GCSE? Exactly. Thank you very much, Manya. This is just a simultaneous equation, isn't it? Meaning that I need to get another equation in terms of A and B that I can solve. Now, we have this bullet point here, right? Is there anything else we can extract from this bullet point? The curve g of x has a stationary point at 2, 9. Is there anything else I can extract from it, or is this it? I want you guys to tell me. Well, remember, a stationary point is a point nonetheless, isn't it? So the point 2, 9 also is a point on the actual graph itself, right? So this just means that when x equals 2, y is equal to 9, right? So remember your original curve, right? Which was this here. This was the original curve. When I plug in x equals 2 into this, I should get 9 out. So we can actually make another simultaneous equation with that bit here, right? So I'm going to say, well, fine. This is going to be 9 here. And then I'm going to have, well, this is going to be a lots of 2 cubed plus b lots of 2 squared plus a lots of 2. Tidying this up, it's going to be 9 is equal to 8a plus 4b plus 2a, right? And if I tidy this up, then this will just give me 9 is equal to 8 and the 2a is 10. So 10a plus 4b. So therefore, I've got 2 equations now. Let me just write these nicely. Equation 1 is 13a plus 4b is equal to 0. And equation 2 is 10a plus 4b, right, is equal to 9. Does that make sense, guys? All okay with this? Yeah. Now you can just solve this simultaneously. Now remember, you can just put this into your calculator if you want, right? You've got a function on your calculator when you can solve simultaneous equations. But this one isn't too bad because all you can do is just say, well, let me just take these away from each other. I will have 3a here, 4b minus 4b is 0, and then this will be minus 9. And that tells me that a is equal to -3. So I now know what a is because it's a simultaneous equation. I'm just going to plug this into one of the equations. I'll plug it into the bottom one. So it's going to be 10 lots of -3 plus 4b is equal to 9. And what's this? This is minus 30 plus 4b is equal to 9. This is equal to 4b. 4b is equal to 39. And that must mean that b is equal to 39 over 4. Does that make sense, guys? So we've got our values for a and b. We all okay with this? Yeah. So therefore, we can say then that our answer to this one here for the actual equation, right? Remember, this was the general equation that we got here. Ax cubed plus bx plus ax, right? This is just going to be, put this here. Final answer is going to be a, which was -3. So -3x cubed B is 39 over 4, and A is minus 3 again. So this is our final answer. Does that make sense, guys? Let me just, so yeah, brilliant. Oh, sorry, I even forgot to put the x squared here. My bad. X squared here, and then minus 3x. That is our answer to g of x, and that will give you 7 marks. Does that make sense? Yeah, brilliant. And then now, the part B, which was only 2 marks, it says prove that the 0.29 is a maximum. This is easy. This is very, very easy because remember, how do you prove that it's a maximum? Well, you just need to differentiate twice, right? And then plug it in. So because we have this now, we can differentiate this. So I'll just do this very quickly. So g dash of x, right, will give us negative 27. 3 times 3 is not 27. That's 9. Oh, I saw it as 3 cubed. This is 9x squared. And then if I bring the 2 to the front, then this is just going to be 2 or 4. It's going to be 39 over 2x, and this is going to be minus 3. Yeah? This is the second derivative. So this is the first derivative, sorry, dash. We need the second one now. So we get g dash of x. We're going to differentiate one more time. It's going to give us minus 18x plus 39 over 2. Right? This is our second derivative. And then now we're just going to plug in x equals 2 because remember the point was at 2,9, wasn't it? Was it 2,9? Yeah, it was at 2,9. So we're going to plug in x equals 2 and see what we get. So plugging this in here, this will give us minus 18 lots of 2 plus 39 over 2. This gives us minus 33 over 2, which is less than 0. And that must mean it's a max, isn't it? Right? And let's just see what they said here. What was part B? Yeah, prove that it's a maximum. So we've done it. Yeah? We plugged it in. We plugged the value where the stationary point occurred, which was at x equals 2, and we plugged into the second derivative, and we got a negative number. That means it's a maximum. And that will give you all 9 marks in an exam. How did we find that question, guys? Put a 0 if it was very confusing, very difficult, struggled with it, or put a 10 if this makes a lot of sense, makes perfect sense. You'll be able to replicate a similar question like this.